In this, there is a circuit shown in which a resistor is connected with an inductor and a capacitor. This inductor and capacitor are connected in parallel. So that means the voltage difference between these 2 points, the PD will be same. The PD will be same. Now, while doing the problems of alternating current, we have to keep in mind the phases. The phase also we have to keep in mind. So if I draw across these 2 points, let us say the voltage is VLC. Now you know that in inductor, the current given in the inductor is 0.8 amps and the current in the capacitor is 0.4 amps. So we have to see these are anti-parallel. Okay, we have to see what is the net value. The net value will be 0.8 minus 0.4, that is 0.4 amps in this direction. The actually the inductor is dominating here. Okay, and there is a phase difference of 90 degrees. Okay, so the voltage is behind, the current is ahead, so the voltage is 90 degrees behind this. So 0.4 amps is the current going through this. So that means through the resistor, how much will be the current going? 0.4 amps is the current passing through the resistor. Okay, so he's been asking what is the instantaneous current value through the resistor. It is 0.4 amps.